So there's a whole host of legally downloadable and distributable 3D STL files on places like Thingiverse and GrabCAD, and Fusion 360 is a great place to create objects from nothing. But Fusion 360 also has a sculpting feature where you can sculpt shapes like they're clay. However, although there are some great videos about how to create an object in Fusion 360 and then convert it into a file that you can sculpt, there aren't a lot of ways that I've found on the web that teach you how to take an existing STL, import it into Fusion 360, and then modify it so that you can sculpt it and then export it again as an STL for 3D printing or laser cutting or machining. So this is my tool chain. I would start with a great video here. I've got the link here. I'll also post it in the comments. And this video very well describes the process of creating a sculpted shape, then converting it into an STL, then OBJ, then loading it into Remake, formerly the Memento software, creating a quad mesh, and then loading that quad mesh back into Fusion 360, and then adaptively remeshing it in the sculpt mode in the utilities feature, and then back to model mode so that you can add parametric components to it. So that's kind of creating a parametric model, then sculpting it, then creating it back into a model you can parameterize. That, like I said, that video was good for that. It didn't help me take an existing STL and sculpt it. So that's what I tried here. I downloaded an example STL. It's a lily pad dress LED button. Lily pad is a little round Arduino card. Thingiverse listing is here. Again, I'll put this in the comments. This is what it looked like when I loaded it into Fusion 360. And then when I applied the process that was described in the excellent video before, in Scott Mason's video, this is what came out. Now, I wasn't using that process for what it was intended for. I wanted to see if that would make this work, and clearly there are some boundary constraint problems. Maybe if I knew either Fusion 360 better or Remake better, this might work, but I don't. So maybe if you know how to do it, please shoot me a note, post in these comments. Additionally, Remake costs about $30 a month or $300 a year. It's a great deal for a commercial piece of software, but this process uses free software. So my process includes downloading an STL from a place like Thingiverse or GrabCAD, open it in Fusion 360, save it as an OBJ, and then use a software program called Instant Meshes to create a quad mesh. And there's a funny bug. Don't forget to type the extension .obj in the prompt save window when you save it. Otherwise, it'll throw an error that took me hours to figure out. Just type that OBJ extension in. Then import that OBJ back into Fusion 360 as a new design, and then convert the quad mesh that you just created with Instant Meshes into T-splines. Now, note, in a lot of the demos that you see on Fusion 360, they just right-click on the OBJ object, and there's the convert option in the menu. When I did it, that convert option wasn't there. You have to uncheck the option Capture Design History on the primary component, not the object you're working on. Go up to the menu tree and right-click on the primary component, and then uncheck Capture Design History. And then when you do that, now go back to the object, right-click on the object. Now that convert option will be available in the menu. That took a good while to figure out. And again, I'll show this all in the screen cap. Now you've got a sculptable T-spline object. But before you sculpt, I want to make sure that you can actually convert the T-splines back to a boundary representation, back to a BREP, which is a necessary step before you export it as an STL. You need to do this because if you export from Instant Meshes, there may be overlapping T-splines and errors that will manifest before you try to save it. So don't go through a whole lot of trouble trying to sculpt it and then find out you can't save it because the mesh you were working with already had embedded T-spline problems. So before you sculpt it, just click on the object, try to convert it back to BREP. And if Fusion 360 throws an error saying something like overlapping T-splines, there is a utilities repair function in the sculpting mode. So go to Sculpt, go to Utilities, use the repair body function, and hopefully that will get rid of those overlapping T-splines. Sometimes you just can't fix it, and there are problems in the mesh. In that case, I've gone back to instant meshes and tweaked some of those refinement options. More mesh vertices, sticking or not sticking to boundaries, etc. There's some trial and error here. And also in Fusion 360, when you're doing the sculpting and the mesh editing, check the box under Utilities that says Improve Performance. That really helps. Once you've verified that you can export that T-spline into a B-rep, then you can go ahead and sculpt. And you want to sculpt those features. When you're done, then convert it from T-spline to B-rep. Hopefully it won't throw any errors because you've already cleaned up those overlapping T-splines. And then export the B-rep as an STL, and now you can 3D print it or slice it in a variety of other manners. So we're going to go through all the processes right now. So again, I started by taking this STL from Web Ahead, the LilyPad LED dress shirt button. So I'll download this. There it is. Export it. Then open Fusion 360. Insert that new mesh. Rotate it so it looks a bit more appropriate. Now that we've got it imported, click on the mesh body, say save as OBJ. We're going to say OBJ exported from Fusion 360. Click save. And now that I've saved that OBJ, I then use a program called Instant Meshes. And I have to be honest, I enter kind of a fugue state when I really take a deep dive. And I do not remember how I found this website. But this is a really interesting free tool. I'll include the link in the comments. But you can download their software. Let's see, where is it? Code and binaries. And they have the precompiled binaries here for Windows. Looks like they've also got Mac and Linux. Open this up. Extract this. And this is a real binary. You got to see old-fashioned MS-DOS prompt. Okay, now here I'm now going to open that OBJ. Let's get it in the on its folder. OBJ exported from Fusion 360. Here we have that nice nice object. Now here's where I had a little bit of voodoo, a lot of trial and error to make sure that we captured all the features that we wanted to keep and had a finely enough refined mesh that I could play with it in the sculpting mode. So first off, check this box for sharp creases because this object has some sharp creases, and it says the mesh needs to be reloaded. So we'll say yes, there it is. I also found that for this shape, about 10,000 vertices was the number I wanted to get to. And this is a little bit of a funny interface where once you click once in this bar, you've changed the number. It tells you, throws a funny error, but we're going to proceed, and then we're going to try to choose another boost the number of vertices again, and keep doing this until we get to about that number. Let's choose around 8,000. Say yes, and now we're going to hit this solve feature where it's going to try to find all the contours and shape, and then I hit this other solve button here, and this shows us a prediction of the grid. And looking at this, I think we've kept the features pretty reasonably well. I'm happy with this. I'm now going to hit export mesh. I like how this looks also. Now I'm going to hit save, and we're going to say quad mesh exported from instant meshes. Oh, funny bug here too. You have to add the .obj extension yourself. So quad mesh exported from instant meshes. Don't forget the extension .obj. And there. I tell you, that took a lot of time to figure out. Now I'm opening instant meshes here, and I'm loading the object exported from Fusion 360. And I'm doing this again because this is a little bit tricky, trying to capture the proper number of vertex counts. I'm also opting to keep to boundaries and to sharp creases. Notice some of these boxes uncheck automatically when you check other ones. This software is a little bit finicky in that regard, so you have to keep an eye on what it changes when you choose certain things. For example, choosing different vertex counts will tell you, it'll throw an error, just power through the error. I found around 18,000 vertices worked for me. Now notice it has unchecked aligned to boundaries again. So I'm going to check on that aligned to boundaries again, boost it to around, 45 is too many, hit no. Try, let's see, 17,000. Sounds a little high, but let's try it. Again, it has unchecked the aligned to boundaries. We'll hit yes again. Let's see if it really stuck to the boundaries. I'm going to hit solve. This is going to find, wow, is it really at 45,000? Yes, it is. Let's go back to closer to 18. Hit solve again. Now let's inspect this guy. We'll hit export mesh. Say extract mesh. And we see there are a few hiccups right here, right here. It's going to be your call about whether your design is robust to these little changes. It is going to make some hiccups when you try to export from T-SPLINE to BREP. There may be some intersecting T-splines that give you some trouble. Let's try this though. I'm going to hit save. We're going to say quad mesh exported from instant meshes. Don't forget the extension, and let's call it number 5, .obj. If you don't add the .obj, it throws an error, another quirk of the software. I'm going to close this. I'm going to open up a new design. I'm going to insert that mesh. So this is number 5 right there. We can see those funny little ripples. Hopefully, since we're sculpting this, the exactitude isn't so important. I'm going to close the insert mesh. Now notice what we want to do is we want to convert this to T-SPLINE. There is no conversion option here unless you go to the full title of the component and choose do not capture design history. It'll throw an error or just warn you. Hit continue. Now if we go back to the object here, voila, the convert option is there. Let's convert the quad mesh to T-spline, hit OK. So now we have our purple sculptable item. This is a T-spline. Before we do any sculpting, I want to make sure that we can export this as an STL. In order to do this, we first need to be able to convert it to a BREP, to a boundary representation. So we're going to do this, and I'm doing this because it does throw an error sometimes, and it's suggesting utilities repair body to remove the error. Notice there's no utilities option here unless you're in the sculpt mode. We are trying to sculpt T-spline, so of course you'd have to be in the sculpting mode. Let's go to utilities. I see a number of options. One of these is enable better performance. Why not? I'm going to check that. I'm not quite sure how this enables better performance. Maybe it caches more RAM. It says switching to faster performance, editing will be faster. Display and analysis may be compromised, so maybe the graphics are a little slower. And now I'm going to go back to utilities, repair body. I think I have to check. There we go. I'm going to hit auto repair here. This takes some time. This is faster with that improved performance feature checked. So I can see an OK here now. Okay, now I'm going to try converting again back to BREP. Let's see. There are times where I've had to do this a couple of times. And again, sometimes it never worked, and then I went back to instant meshes, and I tried different number of vertices, different options like keep within the boundaries or keep sharp creases. And look at that, it did export a BREP. Now I bet you if we right click on here, there's save as STL, so that should work. What I'd like to do now is hide that STL, show the T-splines, and now modify it. So I'm going to choose edit form. I'm going to zoom in a bit. Our selection filter is at nodes, so I'm going to zoom in a bit more. I'm going to choose one. I'm going to shift click, shift left click, shift left click, choose a few of these guys. And then pull them up a bit. Make a little bump. Maybe this is a pin that would seat in an Arduino hole. So I'll say OK here. So there we can see we've sculpted an STL that I downloaded from Thingiverse. Now again, we need to convert this back to BREP in order to convert as an STL. So I'm going to hit convert T-splines to BREP, say OK. And I'm waiting to see it create a new body. This was the old body we created from the original quad mesh of the STL. And look at that. So now we have a BREP, a boundary representation. I'm going to right click on this and say save as STL. I'm going to keep these options. Hopefully up will pop up a window. I'm running a lot of other software on this laptop right now. It's burning pretty hot. Now keep in mind, if you're going to be 3D printing something like this, especially with a fused deposition modeling machine, those little ridges might be lower than the resolution of the machine you're printing with. So I'm not quite sure where the pop-up window is to save. I don't know if it automatically saved it. Nope, not yet. So let's hit OK here. There we go. Okay. So STL exported from Fusion 360 after sculpting, mesh converted from instant meshes. Now, just to prove that everything's kosher, I'd like to go to a viewer. Let's upload that design, select our file. That's the most recent one. That guy right there. Say open. Give it some time to upload. And look at that. There we have our STL, which was downloaded from Thingiverse, and then converted to quads through instant meshes, and then back into Fusion 360, where it was converted to T-splines, which was then auto-repaired to correct some of those T-splines intersecting, then sculpted in the sculpt mode, then saved as a brep, and then exported as an STL. So it's a complicated tool chain, but seems to work. Again, with some iterations and some little bit of love. Any questions, post on the YouTube comments, and I'll try to get back to you. Thanks.